So we have seen the method of separation of variables, and we have solved one first order PDE using the method of separation of variables. It was this PDE that we solved. Now let us see how to solve a second order PDE using the method of separation of variables. For this I consider the Laplace equation in two variables, that is dou square u by dou x square plus dou square u by dou y square equal to 0. And we need to solve it using the method of separation of variables. So what I do is, here u is the dependent variable and u is a function of x as well as y. So u of x comma y. So I'll assume that this u can be splitted as a product of two functions, capital X which is a function of small x and capital Y which is a function of small y. So that's what I have done here. That's an assumption done for proceeding with the method of separation of variables. So in order to solve the Laplace equation, we need the derivatives dou square u by dou x square and dou square u by dou y square. So from here, dou square u by dou x square is what we are treating small y as a constant, since the partial derivative is with respect to x. So dou square u by dou x square will be the second derivative of x with respect to small x, and y will act as a constant. So dou square u by dou x square is nothing but x double dash y. And what is going to be dou square u by dou y square? There you have to treat y as a variable and x as a constant and differentiate it twice. And what you get is x into y double dot, or y double dash also you can put. We follow the notation x into y double dot. Then you substitute it in the PDE. So what you get is x double dash y plus x y double dot is equal to 0. Now you need to separate it into two sides. You have to make functions of x into one side and terms in y into the other side. So what I do is I'll make it into two parts, and you bring this x y double dot to the right side and bring that x down. So x double dash by x is equal to y double dot, and y when taken to this side you will have 1 by y appearing this side and with a negative sign, because this term you are taking to the right side as minus x into y double dot. So this is the equation now, and now from this set of equations you can form two PDEs. One is x double dash by x is equal to a constant, and second one is y double dot by y with a minus sign equal to a constant. Okay, now we solve it by case, and this k, it's a real number, and k can be 0, positive or negative. According to that, you will be having three cases. So in case 1 I assume k equal to 0, then what I will have is x double dash by x is equal to 0. So that will give you x double dash is equal to 0. Now x double dash means nothing but d square x by dx square. And when it is equal to 0, you can say that it is giving you, if you integrate it, you get a dx by d small x is equal to a constant, say c1. And if you once again integrate it, you get x is equal to c1 times small x plus c2. Similarly, you can put minus y double dot by y equal to a constant. That constant is taken as 0 in the first case. So minus y double dot by y equal to 0. So that implies y double dot is equal to 0 and y is equal to c3y plus c4 as in the case of x. So your u of x comma y can be written as the product of x and y. U is equal to x into y. So c1x plus c2 into c3y plus c4. That is the solution in the case when k equal to 0. The solution is very simple. It's a product of linear functions. Now again, I am writing it once again, the two equations, this one and this one, which we need to solve. And the case 2, we consider k to be a positive number. So since k is a positive number, it can be taken as alpha square with the alpha strictly greater than 0. Alpha equal to 0 we have already discussed in case 1. Okay, so k equal to plus alpha square. So x double dash by x is equal to alpha square implies x double dash is equal to alpha square x. So it is something like y double dash is equal to alpha square y, and for that you can write y double dash minus alpha square y equal to 0. Why I am considering this form is I want to remind you of the solution of second order differential equation with constant coefficients, linear second order differential equation with constant coefficients. That's why. So auxiliary equation is going to be m square minus alpha square equal to 0. So m equal to plus or minus alpha will be the roots of the auxiliary equation. And therefore the solution, here in place of y we have capital X, and in place of small x we have small x itself. So the solution is going to be c1 into the first root is alpha, right? So x is equal to c1 e raised to alpha x plus c2 e raised to minus alpha x. Now what about the second one, second equation? It is minus y double dot by y equal to alpha square. So you can write it as y double dot plus alpha square y equal to 0. So again you have plus here. So it will be nothing but y double dash plus alpha square y equal to 0. This kind of an equation. And the auxiliary equation is m square plus alpha square equal to 0. So you get m equal to plus or minus root of minus alpha square. So that's going to be m equal to plus or minus alpha I, because it's going to be the roots are going to be purely imaginary numbers, 0 plus or minus alpha I. Therefore the solution is going to be y equal to e raised to 0x, because the real part is 0 here, into some constant into cos alpha y, because here you have to be careful. Y double dot means d square y by d square capital Y by d small y square, because capital Y is a function of small y. So you will be having the solution of this particular differential equation as y equal to e raised to 0x c3 cos alpha y plus c4 sin alpha y. And taking the product of these two, you get this and this, you get the solution in the case when k is positive number. So u of xy is equal to c1 e raised to alpha x plus c2 e raised to minus alpha x, which is this product with this expression for y. So c3 into cos alpha y plus c4 sin alpha y. So you get the solution for case 2. Now case 3 is the case when k is a negative number. So k is equal to minus of alpha square. So you solve the first equation, you get x double dash is equal to minus alpha square into x. So the auxiliary equation is going to be m square plus alpha square equal to 0. And you get the roots of the auxiliary equation to be plus or minus alpha I. So the solution of capital X of x is equal to e raised to 0x into c1 cos alpha x plus c2 sin alpha x. And the other case, that is the second equation, gives you minus y double dot by y equal to minus alpha square. That implies y double dot is equal to alpha square y. So m is going to have positive roots, real distinct roots. And you'll have y is equal to c3 into e raised to alpha y plus c4 into e raised to minus alpha I. Actually, these two cases will be interchanged in case 3, because one case it is positive and the other case it is negative. Now getting this x and y, you can write the solutions u as the product of this x and y. So u of xy is equal to c1 cos alpha x plus c2 sin alpha x times c3 e raised to alpha y plus c4 e raised to minus alpha y. So this is how we solve the Laplace equation using the method of separation of variables. Thank you.